Welcome everybody to the Introduction to Computer Science episode 2. So in this video we're going to be talking about binary. And binary is just a number system that uses two numbers, hence the prefix bi, and it's 0 and 1. Those are the numbers we use in binary. And this is how the computer represents all the data. As humans, we use the decimal number system to represent our data. So we use 0 through 9 because those are 10 numbers, just like that. So we have to figure out a way to translate our data into something that the computer can recognize and represent, which will be the binary number system. So let's talk about the fundamentals of how the decimal system works. So we start at 0 and then we go up to the max number. So we're in the ones digit place. We go up to 9 like this, and then we reached our max number, so we have to revert that back to 0. So we take that back to 0 and we add a digit place at 1. That's where the 10 comes from. And then we keep going, so 1 1 and then 1 2 and then all the way up to 1 9. And then again, the 9's place is, or rather the 9 is in the 1's place, so we have to increase the 10's place by 1 and revert the 1's place back to 0. So this would become 2 0 20. And then we just keep doing that until we reach 99, and then both are at the maximum number. So we add 1 to the 100's place, so 1, then revert the 10's and 1's place back to 0. Just like that. And that's how the decimal number system works. And we'll find that the binary number system works in a very similar fashion. Okay, so let's go ahead and talk about binary. The way in which binary works is very similar to how the decimal system works. So we're using the numbers 0 and 1. And in the decimal system, we started at our minimum. And the minimum is always going to be the same. It's always 0. So then we added 1, so we'll change that to 1. And now notice how in binary 1 is our max number instead of 9. So we reached our max, so we have to add a number place and revert the 1 back to the min. So we have 1 and then we revert to 0. And then since this is not at the max, we add 1 to it, so it becomes 1 1. Now we see both are at the maximum, so we have to add a numbers place. There's our new number place. And then we revert both back to 0, like so. And then we add 1 to the rightmost, so 1 0 1. Alright, and then we, this is at the max, the rightmost is at the max, so we add 1 to the left digit place, and then we revert to 0. So 1 1 0. And then we see that 0 is not at the max, so we go 1 1 1, and now all are at the max, so we go 1 0 0 0, like so. And that's how binary works. Let me show you what some of these numbers actually represent though. We're working with two numbers, so it's going to be a number to the base of 2. So if we look at some of these decimal numbers first off, we can see 1 0, it's to the power of 10. So this is the 1's place. Let me mark this 1's place, and then this is the 10's place, and the next would be the 100's place because it's a number to the base of 10. So this first digit place right here is 10 to the 0, and then this is 10 to the first, and then 10 to the second. So this is 1 10 100. So we have 0 in the 1's place, so 0 times 1 is 0. And then in the 10's place, we have 1 times 10 is 10. So 10 plus 0 is 10. That's how our number system works. Now if we look at the binary number system, if we take, let's look at this number, for example. So we have 1 0, and we'll do 2 to the 0 for the first place, and then 2 to the first for the second place. So this is 1, and then this is 2. So we have a 1's place and a 2's place. So we have 0 in the 1's place, so that'll be 0 plus whatever 1 times 2, which is 2. So this is equal to the number 2 in decimal. Okay, let's look at another example. So we'll look at this one right here. So we have the 2 to the 0 place, to the first place, and to the second place. So this is the 1's place, this is the 2's place, and this is the 4's place. So we have 1 in the 1's place, so 1 times 1 is 1, plus we have 0 in the 2's place, so 0 times 2 is 0, and then we have 1 in the 4th place, so 1 times 4 is 4. So this number is equal to 5, and that's how binary works. Okay, so now that we understand a little bit more about binary, let's see how we can convert straight from decimal to binary. As you can see, we just converted from binary to decimal. Let's go the other way. So let's take a random number, I'm thinking 15, and how we do this, a neat little trick, is we just divide this number by 2 until we can't. So 15 divided by 2 is 7, because 7 times 2 is 14, and we write the remainder on the right side. So we have 1 as the remainder. 7 divided by 2 is 3 with a remainder 1. 3 divided by 2 is 1 with the remainder 1, and now 1 doesn't divide by 2. So we have our binary number 1, 1, 1, 1. So 1, 1, 1, 1 is 15, and if we were to convert back to decimal, that would convert to 15. So that's a neat little trick to convert decimal numbers into binary numbers. Okay, so we've seen numbers represented in binary, but how do we represent letters? Well, we just use something of a table. There are 2 significant tables that I want to mention. There's a table called ASCII, and there's another one called Unicode. So these are 2 standards that are used to represent letters in binary. The only difference really is that Unicode is a lot bigger and expansive than the ASCII, so it has a lot more characters, and the ASCII is smaller, but you can still represent all the letters. So if we take an example of the letter capital A, in the ASCII chart, you can find that it has a value of 65. So now that we have a number for it, we can convert it into binary. So the binary number for 65, well, let's just do our trick. So 65 divided by 2 is 32, remainder 1, and then 16, remainder 0, 8, 0, 4, 0, 2, 0, 1, 0. So that's the number for 65, 1, 0, 0, 0, 0, 0, 1. And that's how you represent capital A in binary. Okay, so we've taken a look at how binary works and how it's similar to decimal, and how we can convert to and from both of those number systems. We've also talked about how the letters can be converted into a binary format. Now we need to talk about why we actually use binary. So in computers, I mentioned in the last video that all computers are just machines made of wires. So here's a machine made of wires, and wires conduct electricity. So a wire can be either off, so denoted by the red wire, or it can be on, denoted by this green wire. So it has 2 states, 0, 1, off, or on. That's why we use binary.